Okay, chapter 2 is over methods of social psychology. So this is how social psychology is studied, how it is measured, how it is experimented. And so this is very important to know so that you know how we know all of the knowledge that we're going to learn throughout the semester. How are these ideas tested? How are these theories tested? Um, so let's get into it. Okay, so what is the value of social psychology research? So there are findings from social psychology that can inform us on heavy issues such as growing income inequality, climate change, biases among minority students in schools, sexual harassment, et cetera, et cetera, et cetera. Studying social psychology can inform us on so many social, political issues because we're studying people and how they interact with one another. It can also inform us on everyday issues such as dating, interviews, political discussions with friends. And that leads us to hindsight bias. So, whenever we are studying social psychology, we have a tendency to be overconfident. Well, studying anything, we have a tendency to be overconfident about whether or not they could have predicted a given outcome because of what you may observe in the world. But whenever you break down uh, a study and you see the actual results, you have hindsight bias and say, oh, yeah, I totally would have seen that. So it's after you know the results of a study, the data, you think, oh, yeah, I knew that. But really you didn't. It's a tendency to be overconfident about whether you could have predicted any kind of outcome. Okay, so how do social psychologists test ideas? How do they study social psychology? There's a wide variety of methods by which to study human behavior. Even if you can't conduct a study because of insufficient resources or ethical concerns, there are lots of maybe you have a lack of money, lack of resources, lack of whatever instruments you need to study, a lack of people, whatever it is, that can make it hard to conduct a study, or ethical concerns such as um, maybe exposing people to something that could be a topic that could be triggering or something that could be dangerous or too intrusive, whatever that may be. If you can't conduct a study because of those reasons, thinking through how you would test that can bring about new ideas. And this is called a thought experiment, kind of thinking through, okay, well, if I did undergo this study, what would that look like? And that's a thought experiment. And that could bring some new ideas, maybe as to a different way to study the topic, or bring about new ideas in the realm of social psychology. So when conducting a study, you need to know the basics. So I'm sure a lot of you guys know the scientific method. So the first step is the hypothesis, a prediction about what will happen under particular circumstances. So this is before you've done any any research, any you haven't conducted any part of the study, the experiment, any of that. This is just a prediction about what will happen. And then a theory is a set of related propositions intended to describe some phenomenon or aspect of the world. So this is after a whole study has been done, the experiment has been done, you have all your data, and it's replicated over and over and over again, and it turns out to be, you believe it to be true. It's not a law, but it's pretty well accepted. That's a theory. Okay, observational research. This is another type of research in the realm of social psychology and other realms, but we're specifically talking about social psychology. And so this is looking at a phenomenon in a systematic way with a view to understanding what is going on and coming up with hypotheses about why things are the way they are. So this would include participant observation. So you're not, adding one. It's not like a scientific experiment where you're adding one chemical to another or whatever. You are just simply observing person to person interactions. That is what you're doing. So participant observation. So you're observing some phenomenon at close range, such as living with a group of people for a time. So maybe you're wanting to learn about social behavior in an isolated tribe of people. So you would go and live with them or live close to them and just observe the way that they interact with one another. And that would be your research, your observational research. So you take notes and interview participants. However, observations can be misleading, so any tentative conclusions gleaned from observations should be tested using other methods because you may only see one aspect of a situation. You don't know the deep ins and outs of those people. And so by just observing, you're not necessarily getting the whole story. So observational research is not absolute. Okay, next is archival research. And this is the kind of research you will be doing when you do your paper. Wink, wink, remember this. Please remember this. Archival research is the kind of research you'll be doing whenever you do your paper later in the semester. This includes researchers can look at evidence found in archives of various kinds, including census reports, police records, sports statistics, newspaper articles, and databases. So whenever you write your paper, you're going to be looking at previously published journals and articles about whatever topic you are going to do your paper on. And you're going to gather information from all of those sources and write a paper about your findings. So this is the kind you'll be doing when you write your paper. You're not conducting your own study, your own experiment, whatever it is. You're going to be writing a paper 100% from what other people have discovered. Okay, surveying and sampling. So surveys can be conducted using either interviews or written questionnaires. Whenever I was in grad school, I got my master's in general psychology at Northwestern. I did a study where I sent out through Facebook a Google Docs questionnaire, and it went out to friends, family, friends of friends, friends of family, whoever was connected, several steps in through Facebook. And they completed this anonymous survey or questionnaire. And so I got my answers that I needed. And you guys may be doing this if you are psychology majors. As seniors, you'll probably be doing this as well. So they can be participants can be a small collection of students or a large sample of the national population. It really depends on what your subject, what your topic is. So there's a difference between representative sampling and convenience sampling. So say you are talking about Northwestern students as a whole, and you are wanting to know kind of a general consensus on what Northwestern students think about a given topic. And so you're going to send out a survey, or you're going to ask students as you walk by them. So you're going to interview students. So using this surveying method, you're going to interview students on campus and ask them what their thought on the presidential election or whatever it is. So if you stand just in one building, like say the education building or the fine arts building, you're only going to get a certain type of student. So in the education building, you're only going to get education and psychology majors, maybe a few different majors here and there, but you're not going to get a true sample of the whole student body. Or say you're in the student center and you ask, the students that are around there, but it's majority football players are all hanging out together. That is just one group of people. You are not going to get a true sample of what the whole student body thinks. So that would be an example of convenience sampling. People are sampled simply because they are convenient sources of data. And this may be biased in some way. If you're asking only one type of student, or roughly one type of student, then the results are maybe going to be skewed one way. So that's why we need a representative sampling. The people in the survey must be representative of the population. And so in the next slide, I'm going to show you kind of a picture of what that looks like. So information based on biased samples is sometimes worse than no information at all. If it's biased, it's not accurate. So why even get the information to begin with if it's not going to be a true representation? So the top picture is the whole population, just a snippet of the whole population. So this is the group you want to know about. So for example, US college students. So if you do, so we have a few pink, several blue, and a lot of green in this population. That's what the whole population is, okay? So for a random sample, you are likely to capture the proportions of given types of people in the population as a whole. So we only have one pink, and there's only a few pink in there. And we have 3 green to 2 blue. And that's about the ratio in the total population that we're getting. So we're going to get a pretty good idea of what the whole population thinks of. So we're going to get from these 6 people, we're going to get a pretty good idea of what this whole is thinking. However, convenience sampling can produce proportions that are severely skewed away from the actual proportions in the population as a whole. So if we see here, we've got 3 pink and 3 green. Well, that is not an accurate representation of this population because we've got no blue. We've got way too many pink and probably the right number of green, but we've got no blue in there. So it's going to be skewed because we're not getting an accurate representation of what the whole population is. Okay, the next kind of research is correlational research. So you need to know that there's a difference between correlation and causation. You've maybe heard correlation does not equal causation. So correlational research is research that involves measuring 2 or more variables and assessing whether there is a relationship between them. Simply a relationship. A correlation is a relationship. It doesn't mean that it caused it. It just means that there's a relationship. So you could take 2 people and one person drinks only water and the other person drinks milk, juice, water, soda, whatever. But the person that only drinks water, never exercises, is sitting on their behind playing video games and watching TV all day, every day, eats a lot of junk food, but they only drink water. Then the other person who drinks all sorts of things, exercises 4 to 5 times a day, 4 to 5 times a week, has a pretty active job, eats pretty healthily, but likes her drinks. Well, overall, I would say the person that drinks a variety of things is probably healthier. But if you're just looking at correlation, you would say that drinking water may make you unhealthy because the person that is less healthy, that does not get off the couch very much, that does not eat very healthily, they drink water. But that doesn't mean that the water is causing them to be unhealthy. It just means that there's a relationship between the two in this instance. So the water does not cause someone to be unhealthy, but there's a relationship between the water and someone being unhealthy because the person that is unhealthy is drinking the water. Okay, I hope that makes sense. Okay, and experimental research is research that randomly assigns people to different conditions and that enables researchers to make strong inferences about why a relationship exists or how different situations can affect behavior. And then there's a third variable. So whenever we're talking about, we're going to talk a little bit later about independent and dependent variables, and those are the 2 variables that we worry about when conducting a study. But what if there's something in the background that's actually causing the change? It's not the 2 variables that you're studying. That's what a third variable is. It's a variable often unmeasured in a correlational research that can be the true explanation for the relationship between the 2 other variables. Self-selection is the situation in which the participant, rather than the researcher, determines the participant's level of each variable, thereby creating the problem that it could be other properties that are responsible for the observed relationship. So if you're trying to find a true study, you want to do an experimental research, because if the individual that is participating in the study gets to decide the levels of their participation and what variable they're going to be a part of, well, then that can skew the relationship, and could cause a third variable to therein actually be the cause. Okay, and then a longitudinal study is a study that is conducted over a long period of time with the same participants. So this table right here is talking about correlation. So if we've got a perfect negative correlation, that means, for example, say you're growing a plant, okay, and you're studying how much a plant grows in with the amount of water that they get, okay. So maybe it's a plant that does not need much water, so the less water it gets, the more it grows. So this is amount of water, and this is how much it grows. So the more it grows, the less water it needs. That would be an example, okay. Now here, if you say you're talking about water and plant growth, these three would be not a perfect correlation. This would be kind of a slight relationship. You kind of see it trending one way or the other, but there's no line. A line can be drawn straight through there. A line could be drawn straight through there. Perfect positive and perfect negative correlations. This middle one has absolutely no relationship. There's no relationship between the two variables that you're studying. Okay, it could say it. So for the plant and the water, it would say that it does not matter how much water you give, the plant is going to grow or not grow either way. Okay, and then a perfect positive correlation would be the more water you give the plant, the more it grows. Okay. Okay, so we just talked about the third variable. So now let's get into independent and dependent variables. The independent variable is the variable that is manipulated. So in terms of how much a plant grows, because the amount of water you give it, the amount of water is what can be changed. So that is the independent variable. In that situation, the dependent variable is how much the plant is growing. That's the variable that is measured. Okay, random assignment is assigning participants to different conditions randomly, so they are as likely to be assigned to one condition as to another, and that would be a part of the experimental research that we just talked about on this slide, not the self-selection study. Okay, the control condition is a condition comparable to the experimental condition in every way, except that it lacks one ingredient hypothesized to produce the expected effect on the dependent variable. So let's say the control condition is you are giving the exact amount of water to the plant that the paper tells you to do. You know, you get some seeds and it tells you this is how much you're supposed to water the plant every day or every week. And you're going to give it exact that amount. Okay. So there's no change in the amount of water you're giving it. You're giving it the same amount of water every single day. But the other ones, the other plants that you're going to be studying, some are going to get a very little amount, some are going to get none, some are going to get a ton. So you need one control where you're giving it the same amount all the time, exactly what is specified, to see which actually works. Okay. And then a natural experiment is a naturally occurring event or phenomenon having somewhat different conditions that can be compared with almost as much rigor as manipulated events. So this is studying something that is happening naturally, not an experiment that you're setting up. Okay, so what is the criteria of sound research? We need to be conducting sound research, which sound research means that it is good, okay, that it is true, it is unbiased. You're getting good information from this research. So all research is not created equal. What sets a well-designed study apart from a flawed one? So we're going to look at validity and reliability. So first, we're going to look at validity. External validity is how well the results of a study pertain to contexts outside the conditions of a laboratory. So what you're going to ask yourself is, will this happen in the real world? You may be throwing out all possibilities of a third variable by doing something within a laboratory, but will this translate into the real world? Is the research we're doing, is this going to make a difference in the real world? Because yes, it may give us the results we're wanting in a laboratory, but is it going to do the same thing when there's lots of other factors going on out in the real world? So I like to give the example of perfecting the free throw. So maybe you are in a lab situation, you are all by yourself, there's no pressure, there's no nothing, and you have found the exact specific mechanics to perfecting the free throw shot in basketball. Okay, so you conduct this study and you post the results. You have the data. Okay, will this happen in the real world with all the mechanics given properly? What are things that could affect the reliability of your free throw shot? It could be pressure. It could be exhaustion during this is in the real world, exhaustion while playing a game. This could be the sound from the crowd, the noises, the pressure from the crowd. There are so many things that can affect how perfect your free throw shot is in the real world. Third variables that are affecting your accuracy, that maybe it does not have complete external validity. Okay. One of the best ways to ensure external validity is to conduct a field experiment. An experiment conducted in the real world, usually with participants who are not aware they are in the study. Okay, so maybe you give this basketball player the exact mechanics. Maybe you show them, this is exactly how I want you to do a free throw, and they do it during a game, during a normal basketball game, and see how accurate it actually is. Okay, next is internal validity. This is confidence that only the manipulated variable could have produced the results. There is no third variable. So we need external and internal validity in order for our research to be sound. Okay, next is reliability. This is the degree to which the particular way researchers measure a given variable is likely to yield consistent results. This is typically measured by correlations. So is this person making the free throw shot over and over and over again, or are they missing 50% of the time? And then measurement validity is the correlation between a measure and some outcome the measure is supposed to predict. Oh, I'm sorry. The correlation between a measure and some outcome the measure is supposed to predict is what that's saying. So whenever we are talking about reliability and validity, this is an easy way to break it down. And we're not talking about external and internal validity, just reliability and validity in general. And I need you to remember this. This is very important. So you can have reliability without having validity, but you cannot have validity without reliability. Okay, so I'm going to go back to the free throw shooting. So let's say that I shoot 10 free throws. Okay, I shoot 10 free throws and I miss 9 of them. Would you say I'm reliable? Some people would say, no, you're not reliable. You hardly made any. And I would say, oh, on the contrary, I am reliable. I am reliable to miss it. I'm yielding the same results over and over and over again. Okay, 90%, that's pretty reliable. 90% sure that I'm going to miss it. You can rely on me to miss it. But am I correct? No, I'm not correct. I'm still missing. Okay, so I can have reliability without validity. I can yield in an experiment the same results over and over and over again, even if they're not accurate. Okay, however, I cannot have validity without reliability. If my results are not reliable, if I'm not producing the same results over and over and over again, well, then there's no way for it to be accurate. Okay, so say I shoot 10 free throws and I make 4 of them and miss 6 of them. I'm not reliable and I'm not valid either. But if I have reliability and validity, that would be shooting 10 free throws and making 8 or 9 of them. If you can count on me to make them 80 to 90% of the time, that's an amazing free throw percentage. Okay. So I would be reliable and valid. My free throw percentage would be reliable and valid. So you can have reliability without validity, but you cannot have validity without reliability. Please remember that. Okay, next on to statistical significance. And if you've taken statistics, you probably know this. If you haven't, this gives you a little insight into some of what you're going to learn in statistics. So a measure of the probability that a given result could have occurred by chance alone. So you need to, sometimes things just happen by chance. They happen the way that you think they're going to happen by chance, not because of how much of a variable you changed, whatever it is. So we need to test and see how likely it is that the results we got occurred by chance alone. And the goal is less than 1 or 20 or 0.05. This is primarily determined by two factors. One is the size of the difference between groups in an experiment, or the size of a relationship between variables in a correlational study. And then two is the number of cases on which the finding is based. Okay. The chance needs to be less than 1 in 20. So whenever you see maybe a statistical equation or result, and you see P is equal or less than 0.05, that is what you're looking for it to have statistical significance. Okay. Next is replication. This is reproduction of results by the original investigator or by someone else. If a result is genuine or valid, it should be possible for scientists to replicate it. So that's why it is so important to record exactly what you do every single step, so that you and or someone else can repeat the experiment, because the more it is repeated and the more the results are reliable, that increases the validity of your research. Okay. If a result is valid, it should be possible for you or someone else to repeat it and get the same results. And through replication, that leads to open science. This is practices such as sharing data and research materials with anyone in the broader scientific community in an effort to increase the integrity and replicability of scientific research. This is also known as full disclosure. Like, hey, this is exactly what I did, and I'm not hiding anything from you. These are the results I got. These are the exact steps I took. And if you want to do it, you can do it too. And I guarantee that you'll get the same results, because this is exactly how I did it, and you can do the same. And that leads to trust within the scientific community. Okay, so there may be some ethical concerns that you run into while wanting to conduct an experiment. And that is why IRBs, or institutional review boards, are put into place. This is a committee that examines research proposals and makes judgments about their ethical appropriateness. This includes at least one scientist, one non-scientist, and one person who is not affiliated with the institution. Northwestern has an institutional review board, and you will submit, whenever you do your senior project, you will submit your proposal to the IRB, and they will accept it or deny it, or accept it with conditions and saying, you can't ask this question, or you can't do this, or only if you do this, because they are the ones that are looking for possible ethical concerns. However, research may be allowed even if it makes people uncomfortable or embarrassed or causes physical pain, as long as the research is deemed sufficiently likely to yield scientific information of significant value and the discomfort or harm to the participants is not too great. So whenever I did my master's a few years ago, and I did my study, my experiment, mine was over breastfeeding outcomes and postpartum depression on, breastfeeding outcomes and maternal support on the significance of postpartum depression symptomology. Okay. And I had to ask questions about suicide and about harming yourself or harming your child. And those are some very ethically gray questions to ask someone. Okay. Those bring up some really tough conversations. And it was anonymous. I had to make sure it was anonymous. But because the research I was doing was deemed to have significant value, and the discomfort or harms to the patient to the participants were not too great, they allowed me to continue with asking those questions of the participants. So that's where kind of the line is drawn. Okay, you must give informed consent. This is a person's signed agreement to participate in a procedure or research study after learning of all of its relevant aspects. So the first page of my study, of my questionnaires that I sent out through Facebook, it had a place where you click to accept the agreement. It explained exactly what I was studying, kind of some of the things that I was going to ask, and that person had to agree to participate in the study. Okay, next is deception research. This is research in which participants are misled about the purpose of the research or the meaning of something that is done to them. And this would be, I think this is unethical, but it could be to not let people know that they are part of a study, so you can maybe get even more accurate readings, more accurate findings, because if people know they're part of an experiment, they may act differently or say something differently. And then debriefing is telling the participants of a study about the goals of the research project, whether it's before or after the study has been conducted. So just telling them all about it. So next is basic and applied science. These are two different types of sciences when conducting experiments or studies. So basic science is science or research concerned with trying to understand some phenomenon in its own right, with a view toward using that understanding to build valid theories about the nature of some aspect of the world. So that's just basic science, okay? Applied science is science or research concerned with solving important real-world problems. So you're planning on applying what you have learned from your study to solve a real-world problem. Okay, and then interventions are an effort to change a person's behavior, and those may be used during a study. You may be trying to intervene and try to figure out and stop why certain people act the way they do. Okay, that is the end of chapter 2.